This problem is considered a rate and accumulation problem because we're looking at a rate function. And we should be aware that oftentimes on the rate and accumulation problems, we are going to integrate the rate to come up with an accumulation. This is from the 2010 exam, AB question number 1. In fact, I think within just the 2010 exam, there was like 3 or 4 questions which I would classify as rate and accumulation. So that should speak to the significance of this idea of calculus. There's no snow on Janet's driveway when it begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at this rate. In cubic feet per hour, T is measured in hours since midnight. So 6 a.m. would be times 6. The rate G of T in cubic feet per hour in which Janet removes snow is shown here. So from 0 to 6 a.m., Janet does not remove any snow. From 6 a.m. until 7 a.m., Janet is removing 125 cubic feet per hour. And from 7 to 9 a.m., she has gotten a little more tired, and so she's shoveling a little more slowly. Or maybe it's just harder to find the snow. Who knows? Part A, how many cubic feet have accumulated on the driveway by 6 a.m.? So part A is asking us total accumulation over 6 hours. Total accumulation over 6 hours of the snow that has fallen. F of T dt. That's all we have to do for part A is evaluate this integral expression. Because the question is a calculator active question, we can turn to our calculators, and because we are studious and thoughtful math students, we recognize that this has a trig function in it, and therefore our calculator mode must be in radian. Once we're in radian mode, Math 9 pulls up the integral command, 0 to 6. And then we type in the function, 7x e to the cosine of x dx. Now I know on the test question it says t's, and on the calculator it says x's. That's fine as long as our variables are consistent. I could have made them t's if I wanted to, but this should spit out the correct answer. And in the end, it matches the key. So approximately 142.275, and it is a volume of snow. Volume is 3 dimensions, cubic feet. This is worth 2 points. 1 for recognizing that you need to integrate the rate function, and 1 for the answer. And they actually don't even ask for the units, so that works, 142.275. On to part B. Find the rate of change of the volume of the snow on the driveway at 8 a.m. So they're asking you the rate of change of volume of the snow. So we have snow being added to the system and snow being removed from the system. This is a rate of adding snow to the system, and this is a rate of removing snow from the system. So if we do f of t minus g of t, that would tell you the rate at which the volume is changing. So specifically, they want to know at 8 a.m., so we want to evaluate f of 8 minus g of 8. That would tell you what is the rate of change of volume at time 8. This we can evaluate from a calculator, f of 8. We can either manually go through the process of going 7 times 8, 7 times 8, e to the cosine of 8. That would give you the value of the function, or if you plugged it into your y equals, you could then use the table by going to your table and typing in 8. Either way, we get 48.417, and from that we subtract g of 8. G of 8 is, we go to the table, g of 8 is 108. So subtract 108. And this gives us a value of approximately negative 59.582. Or the AP readers will accept rounded or truncated. So negative 59.583 if you're the rounding kind. This is how quickly snow is being added or taken away from the system. Since this is negative, the rate of snow removal exceeds the rate of snow add-on. So she's doing a good job. She's keeping up with the snow and removing it all. In part B, it does not say anything about units, but if you were to do this, it would be cubic feet per hour. Okay? 1 point if you have the right answer.
All the single men, all the single men, all the single men, all the single men, and they go to the pub and they get really drunk and they have lots of beers and they whinge lots and lots and they complain about their exes and they get really drunk. All the single men, all the single men, all the single men, all the single men. Then they go home and play a little bit of Skyrim and they have too much pasta and they feel really sick. Then they cry themselves to sleep and then they wake up in the morning. All the single men, all the single men, all the single men.
On to part C. Now, part C, you can approach it probably and tackle it without doing a high amount of calculus, but I'm going to show you the calculus approach because it's probably what they're really interested in seeing. First off, they're saying age of t is the total amount of snow. So when we're calculating the total amount of snow that Janet has removed, it's going to vary based on the time. So we're going to have to establish 3 time intervals. So the total amount of snow removed on the interval 0 to 6, on 6 to 7, and on 7 to 9. Okay. Whether we use hard brackets or soft parentheses on this, I think is not going to affect the end result. But let's talk about this. How much snow has she removed at midnight? Well, at midnight she's removed 0 snow. She hasn't even started shoveling until 6 a.m. So on 0 to 6, you could say that she has removed no snow. On 6 to 7, the amount that she has removed is going to be equivalent to how much she has removed by 6 a.m. plus the amount that she removes from 6 to some arbitrary value t of her removal rate, GS/DS. Now I've changed the variable to an S here so as to not confuse with the t there, but what this represents is the total amount that she has removed between the hours of 6 and the hours of t. Now it should be noted that that t has to fall between hours 6 and 7. Okay. Now, whether to include the equality on this 6 or this 6, well, you should note that it doesn't matter whether you include it on the top one or the bottom one because both of these would evaluate to 0. So I think it's okay to include it on the top or the bottom, or even both. But if you're including it on both, you're kind of breaking down on the meaning of what a function is. So let's include it only on one of them. The question includes it on the 6. The key actually included it on this 6 up here. But I think the important thing is you only include it once. Okay. Similarly, when we go to the next interval, it's going to be how much I have shoveled, or sorry, Janet has shoveled by hour 7, plus the accumulation from hour 7 to hour t of her shoveling rate. And this, of course, relates to the interval now 7 to 9. This is the calculus setup. I don't think this is clean enough to get you credit, though. We actually need to evaluate these integral expressions. So let's clean up that piecewise function a little bit. The top piece is 0. The middle piece is going to be 0 plus the antiderivative of g on the interval 6 to 7. So that would be 125 t from 6 to t. So 125t subtract 125 times 6. because 1 hour has passed between 6 and 7, she has shoveled 125 cubic feet, so her amount shoveled at time 7 is 125, plus the antiderivative of g from 7 to t. Well, the antiderivative would be 108t, so we do 108t minus 108 times 7. Okay? Now, the key, if you were to go and take a look at that, they express this as 0, 125 times t minus 6, and 125 plus 108 t minus 7. And I think that a studious person might be able to rationalize their way to this answer through their understanding of transformations without doing any calculus. So I think it's achievable to get here without calculus. And their grading even supports that. Their grading is worth 3 points, which is basically each of the 3 pieces, if you're able to identify each of the 3 pieces correctly on 1 and 1. Okay, so that's part C. Wrap this up quickly. Part D. How many cubic feet of snow are on the driveway at 9 a.m.? So if I integrate from 0 to 9 a.m., the rate that I am falling, or the snow is falling, that will tell you how much snow has fallen. From here, if I subtract h of 9, this is subtracting how much Janet has removed from the system. Okay? Now, 0 to 9 f of t dt, we can turn to our calculator for h of 9. We have to turn to that equation that we just created. H of 9 would be plug 9 into this equation here, and we would get h of 9 is 125 plus 108 times 2, which is 125 plus 216, which is 341, 6, 1, 2, 3, 4, yep, 1, 2, 3, 4. So subtract 341, and we need to turn to our calculator to evaluate that integral expression. So math 9, 0 to 9 of our function, which I've stored in y1. And we get, after it thinks for a while, 367.334. And from that value, we subtract 341. And that would tell us the total amount of snow that are on the driveway. 367 cubic feet have fallen. 341 cubic feet have been removed, leaving 26 cubic feet. And given a standard driveway, just for kicks, a 20 foot by 20 foot square driveway would be about 3 inches deep of snow. No, this is now about 6 inches of snow, I think. I don't know. Fun side project. Worth 3 points, 1 for the integral, 1 for knowing you needed h of 9, and 1 for the answer.
All right, like, comment, subscribe, and follow me on Instagram.
Oh, what the? This is the...
No, wait, what? You said I could. I'm gonna.
All right.
Yeah. Follow up. Yeah, and Venmo me some cash. Bet.
If you're throwing cash out, put some in my Bitcoin wallet too while you're at it.
An outro by Nolan.